at, I did not collect page 13, 14, correct? Okay, take a look at page 14, please. Page 14. I have time for 2 questions on page 14 and only 2 questions on page 14. Questions from page 14, please. Yeah. 18. Number 18. All right. Number 18. I get -2 square root, like that, right? Sorry, I'm interrupting your conversation. We're bound for time. I'm not going to give a warning. I'll just toss you. You go see your dean. Okay, so here we go. If I multiply those 2 together, do I get this? Is 144 a perfect square? I hope so. I multiply the exact same number together. So what's the square root of 144? 12. So I get -2 times 12, which gives me an answer of -24, and that's done. Second question. Okay, thank you for listening to directions. I was just looking at page 14 only. There was multiple pages. Yeah. Which one? 19. Yeah. Good? Number 19. Uh-oh. All right. Let's multiply this out. So I'm going to multiply outside, outside, so I get 6. Multiply inside, inside, so I get root 64. Is that okay so far? Is the square root of 64 a perfect square? Yeah, square root of 64 is 8. So my answer comes out to 48. Okay? Okay, I need you to hand forward, please, page 13 and 14 only. Page 13 and 14 only. All right, now I'm going to look at page 15, 16. Page 15, 16, okay? Looking at page 15. And we just had to do the evens on those, yes? Yeah. Okay, so page 15, 2 through 12. Any of those you like to see? Have time for 3 of those. Yeah. 12. Problem number 12, we have... Excuse me. Number 12, I have 7 square root 12, x to the 6th, y to the 4th. Okay? First thing, let's see if I can break. We know that my perfect squares are 4, 9, 16, 25, 36, etc. Okay? So can 12 be broken down to a number times the perfect square to get to 12? And don't say 2 times 6 because neither is a perfect square. So what times what gives me 12? That's a perfect square. Yeah, 4 times 3. So okay. R is the x to the 6th, that a perfect square? It is because it's an even exponent. Is y to the 4th a perfect square? Yes. So those are both perfect squares. So we're going to write this out as I have 7 times square root of 4 is 2, so that's going to come out. 3 is going to stay inside there. What's the square root of x to the 6th? X to the 3rd, good. What's the square root of y to the 4th? Y squared. What do I have left inside my square root sign? 3. Any letters? No. So outside 7 times 2, I got 14. 14x to the 3rd y squared square root of 3 is my answer. Another question on that page. Go ahead. 6. Number 6. Didn't have to do 9. It's evens only. All right. Is 25 perfect square? Yeah. Is everything up here a perfect square? So that's a perfect square. Is this a perfect square? Is this a perfect square? Yeah, because it's raised to an even exponent, so it's perfect square. So the square root of 25 is 5. What's the square root of x squared? X. What's the square root of y to the 6th? Y to the 3rd. There's my answer. There's no longer a radical because the whole thing is perfect squared. Yeah? 10. Okay, so my perfect squares, 4, 9, 16, 25, 36, 49, etc. Okay, is there a number times a perfect square that would give me 50? 25. Yeah, 25 times 2. So let's break that up. So that's going to give me 25 times 2. What would I have to do to y to the 7th to make it a perfect square, or part of a perfect square? Break up the y. So I have y to the 6th, y. Is y to the 6th times y to the 7th? So we still have everything up there, right? All right, so what's the square root of 25? 5. The 2 stays behind, it's not a perfect square. What's the square root of y to the 6th? Y to the 3rd. What's left under the radical? 2 and a y. Done. Done, done, done. One more question from that front page. No? Yeah. Not front. We're good with the front? Yeah, go ahead. Yeah, take your earbud out, please. Number 4, we have root 11. Root 11. That's going to give me root 121. That's got to be a perfect square because I multiply the same thing.
Oh, wrong. You're on. That's 3. Yeah.
Oh, that's how you do 4. Or 3, even though you didn't have to do it. 4. Sorry about that. All right. Root 8 times root 14. Someone have a calculator? 8 times 14. I don't know. Help me out.
8 times 14.
112. Okay, my perfect squares are 4, 9, 16, 25, 36, 49, 64, 81.
Just have a question.
Yeah.
Will that, the square roots, will that be on the test? Like, will they give you a chart of them?
I'll give you those, yeah. If they're not on, then I'll write them on the board. I'll clear space. Cool.
What's our next?
Friday we have a quiz. All right. Quick question. Will 81 go into 112? 81 times the number give me 112. No. 64 times 2. 64 times 2 is 128, so that's not going to work. 49 times 2 and 49 times 3. 49 times 2 is not big enough. 49 times 3 is too big. What about 112 divided by 36? Does that work? What does it go to? How many times? 112 divided by 36. It's 3 times?
Yeah.
Okay. So I get 36 times 3. That's the same thing as 112. The reason I'm choosing 36 is that it's a perfect square. So, square root of 36 is 6. Square root of 3. You just told me that 36 times 3 is 112. Yeah. Okay. Does it work? I don't know. I don't have a calculator. I'm not looking at my hands. You all have technology in your hands. If that's incorrect, I'm just trying to see if it was correct. Someone saying, no, I don't think 36 times 3 is 112. Okay.
Yes.
Oh, it's not right?
Yeah, I told you it was a guess.
Okay, so thank you for the guessing. Now we have calculators out, so let's use them. So 36 times 3 is not 112. 36 divided by 16. It's 2. One 12 divided by 16. It goes 7 times? Thank you. So we verified on a calculator, yes? Cool. All right, so now, are one of those a perfect square? Well, yeah, the 16 is. So square root of 16 is 4, so I get 4 square root 7. Okay, let's flip to the back side. Keep calculators out, please. Page 16, yes? Yep. I'll just do number 14. Okay, so in order to have a letter a perfect square, it has to be raised to an even exponent, right? So let's keep that in mind as we go through. So 6 times 3, that's 18. I have x and x squared, which I'm leaving this way. Why am I leaving it that way? X squared is a perfect square, right? X to the third is not. And then I'm going to take y's. Is that a perfect square? Cool. All right. So now, thinking of my perfect squares. 4, that's 2 times 2, 9, 16, 25, etc. Are one of those times another number going to give me 18? Yeah, 9 times 18, right? Or 9 times 2, excuse me. Square root of 9 is? Square root of x squared is? Square root of y to the fourth is? What's left under the radical? A 2 and an x? Done. All right, don't worry about the word problems. Go ahead and put your name on those. Pass those forward, please. All right. So, as I said, I shortened our lecture today for 3 whole problems. You feeling better today? Okay, 3 whole problems. And I think this will give you enough of a thought of how you could attempt tonight's assignment. So let me get to a clean sheet. The very first problem, we have the square root of 7 over 4. Okay, the 7 over 4 is totally in there. So we have to realize that the rule for this, if I had x over y like this, that'll change to square root of x over square root of y. That's our first step we would have to take. Is that okay? So, using that little skill, what is that root 7 over 4 going to break down to the 2 radicals? What does this break down to? Using that skill. Root 7 over root 4. Once you get to that point, then it's a little more smooth sailing. So they decided a long time ago that you don't like to have radicals in the denominator. And the reason that really came around was it was very difficult to use long division when you were using a radical to divide into something. So they called something called rationalizing the denominator, which means you want your denominator to be a perfect square. Okay? So on this problem, it's kind of nice because what can you tell me about the denominator? It's a perfect square. Everyone agree? So the nice thing is this problem comes down to 7 root 7 over 2. I no longer have a radical in the denominator because I was able to take the square root of the denominator and it worked. That's the first step. Okay? So first step is make sure you have a radical on top and bottom. If the whole thing was under a radical, if it already comes with radical top and bottom, then you're already at the second step. Then this following step is is the denominator a perfect square? If it isn't, let's make it a perfect square. Okay? May I move off this slide? Everyone feel comfortable with? Yeah.
How do you make it a perfect square?
We're gonna get there. Thank you for asking. That's gonna be like on the second problem.
Oh, I see.
Okay, so moving to the second problem. So I already have the square root of 5 over the square root of 8. So this is already at the second step. We have a square root on top and a square root on bottom, right? Okay, so now we want to make the denominator a perfect square. So take a look at the list of perfect squares over there to the side. Is there a number I can multiply by to get that denominator to be one of those perfect squares? If so, what is it? 2, because 2 times 8 is 16. So what I'm actually going to do is I'm going to multiply the top and the bottom by the square root of 2 and the square root of 2. Now let me ask you this. Remember the days of reducing fractions? Like if you had 6 over 8, it reduces to 3 over 4. So you can make 3 over 4, 6 over 8 by multiplying the top and the bottom by 2 and 2, correct? You multiply both the top and the bottom by a number or the exact same thing, it still stays a correct fraction, an equivalent fraction. So on top, what is the square root of 5 times the square root of 2? What is 5 times 2? 10. So what's the square root of 5 times the square root of 2? Square root of 10. What is the square root of 8 times the square root of 2? Square root of 16. Takes us to our next question. Is my denominator now a perfect square? So what's the square root of 16?
8.
It's 4 times 4, right? Okay. So I no longer have a radical on the bottom. Okay, so we're almost done. Last thing we need to think about on this. Does square root of 10 have any perfect squares that are part of it? Meaning, does 4 or 9 or 16 or 25 times some number give me 10? No. So we are in a reduced fraction. We have rationalized the denominator, meaning we don't have a radical in the denominator. And the reason I did that is I multiplied both top and bottom by the exact same. Okay? You okay? Let me go to that last problem. Something look different about that last problem? What do you see? The denominator is not a perfect square. What else do you see? What? There's no root on top. Good, I like it. All right, so let's think. One, we've broken this up. We don't have a root on top, but that's okay. It'll still work for us. Is there one of those perfect squares that are listed to the side that I could get to by multiplying root 12 by another root? Can I multiply a number times root 12 by something else to get to 4? No. 9? 12 times something get me 9? 12 times something get me 16? 12 times something get me 25? You want to go 144? Well, what if I multiply? What could I get to 36? What would I have to multiply times 12 to get to 36? 3? So if I multiply both top and bottom by square root of 3, okay, 5 times square root of 3 is just 5 square root 3. Agreed? On the bottom, 12 times 3 is 36. So on bottom, I now have square root of 36. What is the square root of 36? 6. So finish it. What do you think? You guys want to see some more examples? We have time. I put 3 to make sure I knew I could get through 3, but we get it out of here in 14 minutes. Should we do a couple more examples? Okay, can I move to the next slide? Okay, so I'm just going to make up off the cuff. What do you think? Ready? What's my first step? Set both top and bottom for radicals. Okay? So I get root 8 on top over root 7 on bottom. Still with me? So we're just kind of breaking up the root. Okay, now I want to make the denominator a perfect square. Excuse me. Okay? So 7 times some number might get me one of those perfect squares. Which one do you think? Can I get the 4? Can I get the 9? Can I get the 16? Multiply by 7. Can I get the 25? 49. What do I have to multiply top and bottom by to get to 49? Okay, so I'm going to multiply both top and bottom by root 49, or excuse me, root 7. So on top, I'm going to get root 56. And on bottom, I'm going to get root 49. Just pause there a minute. Does that make sense? Feel good about it? Okay, so what is the square root of 49? 7. So let me bring this down so I have some room. So now we have to ask, and hopefully you have your calculator still out. Can I break 56 down into a perfect square times something else? Let's see. Let's start with looking at your perfect squares. I have 56, so let's go to 49. 49 times something get me 56. What about 36 times something? 25 times something? 16 times something? Try it. 56 divided by 16. Does it come out a whole number? 56 divided by 16. No? It didn't work? What about 56 divided by 9? Yeah. 14 and 4? Yeah. Thank you. So, I recognize 56 breaks down to 4 times what? 4 times 14? Okay. So, I realize that 4 is a perfect square. Okay, it's not a huge perfect square, but it's still a perfect square. Okay, so what is the square root of 4? 2. So 2 is now outside. What's left inside? Root 14. What's left on the bottom? 7. Hey, can I reduce 2 and 7 at all? No, if it was 2 and 8, it would reduce, but 2 and 7 or 2 and 6 would work nice. But this is my exact answer. 2 square root 14 over 7.
As soon as blue starts, you have 8 over 7 for the square root of 8. Like the square root of 7. Why do you multiply that by the square root of 7?
Both top and bottom?
Yeah.
Keep the fraction equal. Stays an equivalent fraction. So think about like 6 over 8 and 3 over 4 is the same thing, right? Because 2 goes into both 6 and 8. So if I take 3 over 4 and multiply top by 2 and bottom by 2, I get 6 over 8. Same exact concept I'm doing. Okay. All right, let's try one more. so I'm missing a radical on top. Agreed? Square root of 20. Oh, shoot. Let's think about our perfect squares that are listed there. What do I multiply top and bottom by to make that denominator a perfect square? You're right saying 4 and 5. You're okay breaking it up, but think about what you could multiply the denominator by to get it to a perfect square. Can I multiply 20 times something to get to 4? Can I multiply 20 times something to get to 9? Can I multiply 20 times something to get to 16? Can I multiply 20 times something to get to 25? Can I multiply 20 times something to get to 36 or 49 or 84 or 81 or 100? I could do 100. What times 20 gives me 100? 5. So what am I going to multiply top and bottom by? So root 5 and root 5. Still with me? So 9 times root 5 is what? 9 root 5, right? I can't multiply inside to outside. And on bottom, root 5 times root 20 is root 100. Agreed? Root 5 is not going to break down. What does root 100 break down to? What's the square root of 100? 10. Can I reduce 9 and 10 at all? No. Outside to outside will not reduce in this case. So 9 root 5 over 10 is the same thing as 9 over root 20. Any questions on what we've done so far?
Yeah. So if there's one number that's outside, doesn't have a radical, you can't multiply it by something.
Right.
Okay.
So it just combines together. It's like an X.
Oh.
So let's throw one little curveball at it. Let's say we had 5 square root 5 over 2 square root 3. Okay? So last example. So root 5 over 2 square root 3. So I'm not worried about the 2, am I? The 2 is going to come along for the ride, but the 2 isn't a radical. Agree? So what could I multiply root 3 by to get to perfect square? Can I multiply root 3 by to get to a perfect square? Go ahead. Yeah. So I'm going to multiply both top and bottom by root 3 and root 3. Look on top. Root 5 times root 3 is root 15. Agree? On bottom, I'm going to get 2 root 9. Is that all right so far?
Yes.
Now, I'm not going to do anything else yet. I just want you to make sure that, does that make sense to you? The problem's not done, but does that make sense to you? I multiply top and bottom by the exact same radical, so it's still an equivalent fraction. Okay? We'll take care of root 15 in a second if we can. What is the square root of 9? 3. So that's the same thing as 2 times 3, agreed? Which is 6. Now, can I break 15 down into 2 perfect squares, or 1 perfect square times a number? So, 4 being a perfect square, 4 times something give me 15? 9 times something? Now we're above it with 16, right? So root 15 is good. Notice I'm not reducing the 6 into the 15 because the 6 is outside of a radical, the 15 is inside of a radical.
Even if it was, could you reduce it?
If it was inside to inside or outside to outside, yes.
But then it would just be a fraction. Or like,
Right. But you just, so you could have something like this. No, I don't even want to go there. Just keep it like that. All right. So your assignment for this evening, no coughing, first of all, is page 17 and 18. Page 17 and 18. Cool? So, someone asked, the stuff that they've done in Schoology, it hasn't really helped their grade yet. It will as soon as we're done with our first quiz. Okay?
I tried to sign in, so you know how like you sign, it says start new attempt.
Uh-huh.
It didn't say anything. It just
When'd you start to log in?
Huh?
When'd you log in?
Yeah, it was